Woohoo! We are live! Yay! And this is yet another video in the whole set that I've made describing multiplying and dividing radicals. And right in the middle of multiplying and dividing radicals, we're going to completely change the subject and talk about conjugates. Conjugates! Woohoo! What are conjugates? Well, in math, there are a couple different kinds of conjugates. Basically, this is things that go together. We'll go with that. So what are things that go together? Well, like peanut butter and chocolate, or strawberries and eating. These are usually two. These are usually like fraternal twins. They're not usually identical. They're usually slightly different. And there are two expressions that can be used together to do something really beautiful. So the first thing we're going to do is, rather than tell you how to figure out what they are, because I know that would be the way a normal math teacher would explain things, I'm just going to do it. And I'm going to show you what the conjugates are, and then we'll talk about how the heck I got them. So I'm going to do it kind of inside out and backwards. So if I have an expression like 2 plus radical 3, my conjugate would be 2 minus radical 3. See what I did there? So the difference is that one of them is going to be a plus in the middle, and one of them is going to be a minus in the middle, and everything else would be the same. Okay. Then someone would ask, well, what if I start with 2 minus radical 3? And I know this is thrilling. I know no one will ever guess. What's this one going to be? You're right. I hope you're right. 2 plus radical 3. So in other words, whichever one I start with, the conjugate, they are conjugates of each other, will just be the one with the opposite sign in the middle. And this is how I was taught to do it. I was taught that whenever you're working with conjugates, and these are conjugates that have to do with radicals, as opposed to maybe another kind of conjugate you might look into, that what we want is we want a number, like a number A, and then say plus, and then a radical of some other number B, and that the conjugate for that would be a minus radical B, if that makes sense. And they are conjugates of each other. Now, there is another way that we can do it. Now, this book is interesting. I brought the bear along. He's not really helpful in this section, but, you know, he's just watching hungrily. If you have negative 2 plus radical 3, I was actually taught that negative 2 plus radical 3, the conjugate would be negative 2 minus radical 3, where, let's see, yellow is my plus. So there's my plus in the middle. And here's my minus in the middle. And that's how I was taught. And, you know, that was fine for, you know, the 160 years I've been alive. But this particular book, which depending on when you're watching this video, perhaps this book has long faded into obscurity, which would not be a terrible thing. And but it's brought up another way to do it. They're suggesting that to look at a conjugate, I would actually change it like so. So let's see, the plus is yellow. I don't know how I feel about this. It is not wrong. You can always tell when I'm a little annoyed by something because everything has to be in the right order. Now that I've got my rainbow, we can talk. So I'm a little annoyed by this, not because it's wrong, but because it is confusing. And so I understand what they're doing. They're looking at it and they're saying, as someone with lots of experience, yes, this would make it a lot easier. However, for a student, I don't think this makes it easier. I think it gives you too many options and makes it confusing. So my tendency would be to say, when you've got a whole number, or in this case, it's an integer, not a whole number, and you've got a radical, go ahead and for the conjugate, just change the sign in the middle. Just go ahead and do it. Doesn't matter what the sign is on the first term. Now, if you want to play with it this way and you feel comfortable with this, then go ahead and use this method. But you understand that this is kind of two different things. Now, the reality of it is all you're trying to do is change the signs. So the one thing you don't want to do is you don't want to change both signs. So either change the sign in the middle or change the sign on the first term. Do not change them both. If you change them both, it won't work at all. And so I can hear you all saying, but wait, what won't work? Why aren't you telling us what we're going to do? Well, because we got to sneak up on it. So that was conjugates. Yay, conjugates. Dun, dun, dun. And now I'm going to apparently change the subject. And I'm not changing the subject completely. It's just a matter of going through each of the moving parts. So now what we're going to talk about is I'm going to put the conjugates to the side and we're going to talk about dividing radicals. And then something called rationalizing the denominator. So the denominator is in a fraction, the part on the bottom, and rationalizing it means making it rational, which means it means not letting it be irrational. So basically what this whole thing means is getting radicals out of the denominator. Oh, there you go. Left out a letter. Sometimes that happens. There are a lot of letters and words. I don't know if they're all really all that necessary, you know. Okay, so first thing we're going to do is we're going to talk about division of radicals to begin with. So division is a complicated beast in algebra. Generally, you're going to notice that we don't use the division sign very often, and that is because it is actually pretty hard to work with. And in fact, what we're going to choose to do is what we've been doing all along. Hopefully you've been noticing, is that we don't ever use the division sign when we can look at a fraction. So fractions are just a symbolic way of looking at division. If you have a radical on top and a radical on the bottom, you're dividing two radicals and they are the same type. So these are both square roots. Or if you're doing a more complicated problem, if they're both cube roots or fourth roots, they have to match, be the same kind of radical. Then you are allowed to pop them into the same radical like this. Just like with multiplication, where we can move them into the same house, here we're going to move them into the same house. It's just a two-story house. And then I'm going to say, oh, well, 16 divided by 4 is just 4, and radical 4 is 2. Aww. Isn't that a happy ending to a story that started out looking a little yucky? So this is what we're going to do to begin with. So let's talk about a couple of different examples. So I've got radical 16x cubed divided by y squared, radical y squared. So, and I am going to say, I didn't write it here, but I'm going to, let me just write it. Assume variables represent non-negative values. So in other words, no absolute value, because that's just going to make everything that much more complicated. So we're going to keep it all out of absolute value land. We're just going to look at the division and the radicals. So first thing I'm going to do is I'm going to write this radical as 16x cubed all over radical y squared. Okay, now remember way back at the first video, and if you haven't watched these in order, then you might want to, I don't have it in front of me, so I can't show it to you, but there are basic rules of radicals. And the first one is, if you can simplify a radical, you have to. There's a lot going on in these two, and I can tell I'm going to be able to simplify. So for example, radical y squared, that's y. And 16 is a perfect square. X cubed has a lot going on. So what I'm going to have to do is I'm going to have to simplify these two. Now, in looking at this fraction or this rational expression, I see that the numerator and denominator, this is 16x cubed, this is y squared, there's no overlap. In this first problem, 16 and 4 were able to simplify down to 4, so bringing them together made sense. These two, completely different. I'm going to work on them separately. So over here on the side, I'm going to work on 16x cubed. So that's, let's see, that's 4 times x times x times x. I'll bring in my bare friend. I will say, okay, so this is a square root, so I want to bring 2. The 4s go running. Yum, yum, yum. And 1 4 makes it out. These x's go running. Yum, yum. 1x makes it out. And I've got 1x that hangs tight. Okay, so that is how I simplify this expression. Y squared, a lot easier because it's just y times y. I'm like, oh, yay. These two y's go running. Yum, yum, yum. The y comes out. Nobody's left. So I just get y. Okay. Now, and again, all assumed variables represent non-negative values, which means no absolute value. Don't have to play with that shenanigans. So over here, I get 4x radical x. So I simplified that one. And down on the bottom, I've got y. Nothing can be canceled, right? This is a y. These are x's and numbers. Nothing cancels. That means I am done. So in order to divide these two, they didn't even mix it up at all. Just one's on top, one's on the bottom. I simplified each of them, and we're done. I'll remind you, there was a second rule that said you can't leave square roots in the denominator, which I had here, but because this simplified, I don't have to worry about it. I am allowed to leave a square root in the numerator. So, and in fact, in this case, there are some things I could do with top and bottom to change it, but I wouldn't be able to get rid of the square roots entirely. So having it up on top is good. That's great. Okay, so that's the end of number 1. Now let's go look at number 2. Now number 2 is a little more interesting in my mind because I've got a 72 on top and I've got a 2 in the denominator, which tells me that I could reduce if I could bring these people together into a single house. So that's what I'm going to do. Rather than working on them separately, I'm going to bring them together since they're both square roots like this. Do I have to do this? No. You've got so many options to simplify this. I mean, if I went through, I could, right off the top of my head, I can think of 2 other ways to approach this. And then there were probably other ways that I wouldn't even think of. This is just the way that I think that's going to get you through with the least number of headaches and the most success. So not necessarily the fastest way, but definitely the most solid way. So I'm going to bring these 2 together into a single radical. So these are sitting here together in the radicand. And then I am going to reduce them. And I'm going to give myself a little extra space because I want to be thoughtful about the fact that some people are reading these notes and not watching the video. I don't know why, because the videos are awesome. But if they're watching these, if they're not watching these, then sometimes the notes are hard to see if I try to smash them all together. So let's spread this out just a little bit. I think I get 36xy all over 1, which is this 36xy inside a radical. So notice by bringing these 2 together into a single radical sign, into that radicand there, I can reduce, and then I don't have a fraction, which is one of the no-nos, and then I can just look at this and go, wait, 36 is 6 times 6, xy. Okay, bring in the bear. 6 and 6. Yum, 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 yum. Sorry, yum, 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 yum. So the 6 comes out and the xy stays inside. And my cat's obviously very excited about this too. Little known fact, cats love radicals. What do you think? Woohoo? So far, okay? So far, this isn't too bad. So these are 2 examples of situations where we divide and there aren't tough problems. Now, what I think I'm going to do here is I'm going to break the video here because the next video is going to be very long. So I'm going to break this up a little bit. The next video, we're going to talk about what happens when you try to divide radicals and it doesn't go well. And the answer is you don't panic, but it is a little bit of work. So the next video, you definitely want to have your support system, get someone around you who's going to tell you you're awesome, get some snacks, hydrate, maybe go for a walk, and then I will meet you guys right back here and we'll do more work with radicals. Woohoo, math on, guys, math on.